6th grade, Module 5, Lesson 5, Classwork. Opening exercise. Here is an aerial view of a woodlot. If AB is equal to 10 units, so AB, meaning line segment AB, right here from A to B, this, it's saying, is 10 units. FE, so look for, here's FE, is 8 units. AF, so from A to F here, is 6 units. And DE, right here, from D to E, is 7 units. Find the lengths of the other two sides. So once we want to find BC and DC. So let's start with BC. So BC goes from there to there, and we're going to have to look at some other things to find out what BC is. So let's look at some other measurements. So I know that AF is 6 units. So this part right here is 6 units. And then I know that ED, or DE, is 7 units. So this part is 7 units. So together, 6 plus 7 would be equal to 13 units. So BC is equal to 13 units. Okay, so let's do DC. So this part right here. I know that the AB up here, this whole thing, is 10. And I know that FE, this part right here, is 8. So I know the whole thing is 10, this part is 8. So to figure out this little piece, I'm going to do 10 minus the 8, get rid of this section. And so this would be 2 units. So then on the next one it says, I'm going to, a whole new measurement. So I'm just going to erase this, because it looks like we're working with the same thing, but with same woodlot, but different measurements. So now DC is 10 units. FE is 30 units. AF is 28 units. And BC is 54 units. So now we need to find AB. So this section right here, AB. And it doesn't tell me anything about that, but I can look and I know that FE here is 30. So this part right here is 30. And then this last little part right here is 10. So 30 plus 10, so AB would be 40 units. And DE, let's see, DE is right here. So what I know is that AF here is 28, so this part is 28 units. And I know that the whole thing is 54 units. So we just want to know this section right here. I can do 54, the whole thing, take away this 28, and I'll have what's left right there. 14 minus 8 is 6, 4 minus 2 is 2, so we get 26 units for DE. All right, discussion. So down here, what it wants us to do is we're going to start finding, or we're going to decompose this figure and find the area based on the measurements that we have. So there are multiple ways we can break this up, and there are going to be different ways to solve all these problems. So we could break it up like this. So we have A, B, and C, and we can find the area of all of those and add them together. That's one way you could do it. You could break it like this. So we have A, B, and C, 3 rectangles like that. Oops. So there are multiple ways to solve all of these problems. So what I'm going to do is I'm going to go back to the original way and have A, B, and C. So let's start with rectangle A. So to find the area of a rectangle, it is base times height. So we have a base of 2 times a height. It doesn't give us the height there, but it tells us the height of C, and these are the same. So this is also 4 meters. So 4 meters times 2 meters is 8 meters squared of A. For B, it would be the same thing. 2 meters times 4 meters is equal to 8 meters squared. And then C, oh sorry, that was C. I had them labeled this way. So then B, down here, this, we have 7 is the base, and then the height, well, we know the whole height is 9, but we just want to know this part right here. So if the whole thing is 9, we know this is 4. So if we take the whole 9 and subtract 4, the part that's left, this would be 5 meters. So 7 meters times 5 meters is 35 meters squared. So if we add all of that up, we would get 35 plus 16 is 51 meters squared, would be the area of that figure. Example 1. The intermediate school is producing a play that needs a special stage built. A diagram of the stage is shown below, not to scale. So they've done it 3 different times. So it says, on the first diagram, divide the stage into 3 rectangles using horizontal lines. So horizontal means that way. Find the dimensions of these rectangles and calculate the area of each. Then find the total area of the stage. Okay, so we're only using horizontal lines. So I'm going to use my horizontal lines to create 3 rectangles. So we made 3 rectangles using 2 horizontal lines. Find the dimensions and calculate the area. Okay. Is that what we just did? I believe this is the same dimensions of what we just did. So you can basically copy everything that we did for here on A, because that's how I broke it up for A. And so just do it the same thing. So let's skip to B, so we're not repeating ourselves. Okay, so B says on the second diagram, divide the stage into 3 rectangles using 2 vertical lines. So now we're going to use vertical lines. We get 2 of them. So it looks like I'm going to have to do it like this. So now let's find the area of that. So I'm going to label that A, B, C. So for A, we have 2 meters by 9 meters. It would be 18 meters squared. So this is 18 meters squared. C is also 2 meters by 9 meters. So this would also be 18 meters squared. And then B, let's see, so we have this whole thing is 7. I know this part is 2, and this part is 2. So if that's 2, that's 2, that makes 4. So I have 3 left. It's 2 plus 3 plus 2 is equal to 7. So it looks like the base is 3, and the height, they have not given us the height, but we know the whole thing is 9. And we know, so the whole thing is 9. Let me use purple. This part is 4. So what's left, 4 plus what would give us 5? 9, it would be 5. So this is 5 meters. So we have 3 meters by 5 meters, which gives us 15 meters squared. And if we add all of those together, 18 plus 18 is 36. 36 plus 15 gives us 51 meters squared, which is good because that is the same thing we got for part A here. It's 1 meter squared, because they are all the same. So it's just showing how you can divide it up differently and get the same thing. So C, on the third diagram, divide the stage into 3 rectangles using 1 horizontal line and 1 vertical line. Okay, so I'm going to use, let's see, I'll do a vertical line there and then a horizontal line there. Label A, B, and C. So let's find the area of A. We have 9 by 2 will be equal to 18 meters squared. Then B, so the whole thing here is 7, but I just want to know this piece right here. So I know that this part is 2. So if that's 2, what's left to get would be 5 meters times the height, this height right here. The whole thing is 9. This part is 4. So 4 plus this would be 5 meters gives us the 9 meters. So 5 meters by 5 meters would be 25 meters squared. And then the last one, C, we have 2 meters by 4 meters. It's nice when they're already labeled. That gives us 8 meters squared. So let's add them all up. 18 plus 25 plus 8 gives me 51 meters squared, which is great because, again, they all have the same area. We just found it in different ways. So this is showing you can use a different strategy as the person sitting next to you, and you can both be correct. D, think of this as a large rectangle with a piece removed. What are the dimensions of the rectangle, large rectangle, and the small rectangle? Okay, so I'm going to outline the large rectangle in orange. Let's find the dimensions of the large rectangle. So large dimensions would be 7 meters by 9 meters. And then the small, this right here, would be, the height is 4 meters by, the whole thing here is 7, this is 2, this is 2. So 2 plus 2 is 4, so what's left for here would be 3 meters, because that would add up to 7. 4 meters by 3 meters. What is the area of the two rectangles? So small, 4 meters times 3 meters equals 12 meters squared. So this one's 12 meters squared. And then the large one, 7 meters times 9 meters is equal to 63 meters squared. So the other one is 63 meters squared. But remember, that includes the whole thing. What operation is needed to find the area of the original figure? So to figure out what the area of this figure is, we would need to subtract, because we're going to take the area of the whole big rectangle and subtract the small rectangle to figure out what the area is of the original piece. So what is the difference in area? 63 meters squared minus 12 meters squared would be 51 meters squared. What do you notice about your answers to A, B, C, and D? Well, they are all 51 meters squared. So what we just did in part D is we had this large rectangle and then we just took out the small one. So they are all the same. The areas are the same. Why do you think this is true? Because we can decompose a figure in different ways and get the same answer. Let's say it doesn't matter how we decompose a figure, the area will always be the same. Example 2. Parallelogram ABCD is part of a large solar power collector. The base measures 6 meters and the height is 4 meters. Draw a diagonal from A to C. So I'm going to draw a diagonal from A to C. Like that. Find the area of both triangles ABC and ACD. Okay, so remember the area of a triangle. Let's do A, B, C would be this triangle right here. So let's start with that one. Area of a triangle is 1/2 base times height. So ABC would be 1/2. Let's see, the base is 6 times the height, or the altitude here, is 4 meters. So 1/2 times 6, let's do 6 times 4 is 24, and then half of that would be 12 meters squared. So that's the area of ABC. If we were to do ACD, so now we're doing ACD, so this one right here, we have 1/2 times the base here. Since it's a parallelogram, these are parallel, so this is 6 meters, times the altitude here is also 4 meters. So that is equal to 12 meters squared. Okay, so B says draw in the other diagonal from B to D. It's getting crowded. So the other one from B to D. Find the area of both triangles ABD and BCD. So ABD is going to be this triangle right here. So let's find the area of ABD. So the length is still 6 meters. So 1/2 times 6 meters times the height here is 4 meters again. So that's 12 meters squared. And then BCD is going to be this triangle right here. Which the length is 6 meters. And the height is 4 meters, so 12 meters squared. So notice they are all the same. Example 3, decomposing trapezoids. The trapezoid below is a scale drawing of a garden plot. Find the area of both triangles ABC and ACD, then find the area of the trapezoid. So ABC would be this triangle. And then ACD is the other one. So let's start with ABC. So 1/2 base times height. So the base is that 8 meters? I kind of colored on top of it. Yeah, 8 meters. times the height, or the altitude here, is 5 meters. So 1/2 times 8 times 5. 8 times 5 is 40, and half of that would be 20 meters squared. And then ACD would be this triangle right here. So the base here is 4 meters. One-half times 4 meters times the height, or the altitude here, is 5 meters. That would be equal to 4 times 5 is 20, and half of that is 10 meters squared. So if this is 10 meters squared and this is 20 meters squared, then together the area of the trapezoid, 10 meters squared plus 20 meters squared, is equal to 30 meters squared. Okay, so now it wants us to do it a different way. So I'm going to erase so I can work with it this way. So now it says find the area of both triangles ABD. So now we're going to do it differently. So ABD. So let's find that one. 1/2 times, see, the length is 5 times the height is still 5, or sorry, the base was 8, not 5. 8 meters times the height is 5 meters. So that's equal to 20 meters squared. And then we have BCD. So BCD is this triangle right here. So the length here is 4 meters. 1/2 times 4 meters times the height here is 5, which would give us 10 meters squared. So if this is 20 meters squared, this is 10 meters squared, then together we could do 20 meters squared plus 10 meters squared is equal to 30 meters squared. So again, the whole point here is that you can decompose it different ways and you will still get the area the same as the same answer. Okay. How else could we find this area? So it's just asking another way that you could decompose it. So another way we could do it, if we wanted, we could use like a subtraction method. We could break it into 2 triangles and a rectangle. So how about I just draw it down here? So we had something kind of like this. So you could decompose it like this and have 2 triangles and a rectangle. You could let's see, we could also put a rectangle around the outside, find the area of the rectangle, and then subtract the area of the trapezoid. So there are different ways to solve this. So let's